Okay, so do you remember up here it talked about the sparkles? It said the sparkles stay in the air for the same number of seconds as it took for the rocket to reach the highest point. Okay, so that means if we're thinking of our scenario, then the time it took from beginning all the way to when the firework exploded, it took 7.25 seconds. So then that means from when the firework exploded all the way until it hit the ground, the sparkles would stay in the air for the same amount of time. So that means another 7.25 seconds. So how many seconds did the sparkles stay in the air? The same amount of time it took for the rocket to explode. All right, so notice that part I, this first question, was about the y value of the vertex. It was about the y. And then these last two questions were about the x value of the vertex. So as long as you knew the vertex, then you'd be able to answer these three questions. Okay, turn it on over to the back. Let's look at those. Okay, then we got green gammas. Green gammas, the a value is still negative, so that means it is also like this. Okay, looks like this. So we're going to say, here's the ground again, and same questions, right? How high is the rocket when it explodes? How many seconds was the rocket in the air? How many seconds did the sparkles stay in the air? So that means this one is going to be my y, the y value of my vertex, and these bottom two are going to be the x value of my vertex. So I just need to find that vertex point right here, and once I know what it is, I can answer these questions. All right, so I look at my form. It is in standard form, so I need to use the x equals negative b over 2a in order to find the x value. So negative b. So b is a positive 12, and the a is a negative 1. All right, so at the top I got negative 12, the bottom I have negative 2. So negative over negative is positive, and 12 divided by 2 is a 6. Well, that came out nice. So 6. So remember, x is in time. It is in seconds. So 6 seconds. So that means here's when the firework exploded. So from time 0 to when it exploded, it took 6 seconds. So that also means the sparkles from when it exploded were in the air another 6 seconds. So part 2 and part 3, how many seconds was it in the air, the rocket? It was 6 seconds. And the sparkles stayed in the air for another 6 seconds. How high is the rocket? We need the y value of this vertex. So this vertex, we know currently it's at 6 seconds, but we need to find the height. So I'm going to plug it in to my formula. So I got negative x, which is 6 squared, plus 12x, which is 6, minus 15. So I'm going to plug all this in my calculator in one go. So notice the negative. Notice the negative. It is not in parentheses. Not in parentheses. So when I plug this in, I got negative parentheses 6 parentheses squared plus 12 parentheses 6 parentheses minus 15 equals, it looks like it's 21. So that means the height, the rocket exploded at 21 feet in the air. 21. So that is part 1, 21 feet. Remember to write your units, feet. Okay, so that is green gammas. It went off, exploded at 21 feet and 6 seconds for the sparkles. Okay, now last one is orange orthogonals. The orange orthogonals. So same questions, right? Part 1, part 2, part 3. So we need to find that, the vertex. So let's go ahead and draw. Looks like that. Here's the ground. Here's the vertex. Okay, so vertex. It is in standard form again. So I need to do x equals negative b. B is a positive 53. All over 2 times a, which is a negative 6. So I got negative 53 over negative 12. Negative over negative is a positive, and 53 divided by 12 is approximately 4.4. We're going to round this to 2. Remember, x is time, so this is in seconds. So from time 0 to the explosion, it was 4.42 seconds. And same for the explosion to when the sparkles stop, 4.42 seconds. So part 2 and part 3 is 4.42 seconds. So now we need to find how high it is. So that would be the y value of the vertex. So I'm going to plug it in. So y equals negative 6. I'm thinking x is, we're rounding it to 4.42 squared. Scoot this over a little bit. Plus 53, 4.42, and then minus 91. So if I plug all of this into my calculator, negative 6 parenthesis, 4.42 parenthesis squared, plus 53 parenthesis, 4.42 parenthesis, minus 91, enter. I'm getting 26.0, I'm going to round it, 4. Remember, this was height, so this is in feet. So how high is the rocket when it explodes? It is actually 26.04 feet above the ground. Okay. So which of these 3 fireworks do you think would be the best for them? So if you're thinking about fireworks, right, you want it to be high because the higher it is, the further you can see it, right, and the better view you get. And you want these sparkles to stay in the air for the longest amount of time. So let's look. The orange orthogonals was 26 feet. The green gammas was 21 feet. And the red rockets was 15 feet. So it looks like 15, 21, 26. It looks like orange orthogonals wins how high. This one is the highest. But sparkles is also important, right? So the orange orthogonals was like almost 5 seconds, so 4.42. Green gammas was 6. And then red rockets, ooh, that one was 7. So red rockets wins for the amount of seconds. But we got to look at both of them together. So which one is pretty much in the middle? So if you look at the green gammas, it was 21 feet high, which was the second highest height out of the 3. And then it was 6 seconds for the sparkles, which was also the second highest. And so I would say green gammas is probably the firework to go with if you're looking for both height and for how long the sparkles would go. So that would be the choice that I would make, green gammas. Okay, now number 5 says, now that you are officially an expert at evaluating fireworks, the Acme Fireworks Company would like for you to write an equation for their new ultimate firework called the golden fractals. Ooh. The company wants the golden fractals to explode. All right, we're about to get some numbers. 65 feet above the ground, and they want the sparkles to stay in the air for 8 seconds. Write an equation. Okay, so I'm going to say golden fractals. Let's see. So y equals 65 feet. Remember, that was my height. That was the y. And then seconds, the time, that was my x. So remember, the time and the height was actually my vertex. So it looks like they want this new vertex to be 8, 65. They want the new vertex to be 865. So that means that when I put this back in, I can actually put this back in to vertex form. So remember, this was vertex form. This is the equation for vertex form. So if this is my h and this is my k, let's plug it in. Let's talk about the a value. Do I want the firework to be shot like this, or do I want it to be shot like this? I want this one. So that means the a value needs to be negative so that it forces this path to go down, which is a normal firework. Okay, then I'm going to plug in 8 for h, so minus 8 and then squared, plus I want the height to be 65. So you could leave this in vertex form, but all the other forms were in standard form. So do you remember how to make vertex form turn it into standard form? That's what we did on Monday. So let's see if you can do it. So remember, I like to keep the negative in the front and multiply out this x minus 8. So if you come out to the side and multiply x minus 8's together, you get an x squared, a negative 8x, another negative 8x. And notice a negative and a negative makes a positive, and 8 times 8 is 64. So this is going to make x squared, negative 8x, and a negative 8x is a negative 16x, and then a positive 64, and then I have that plus 65 on the edge. Okay, so I'm going to distribute the negative into parentheses, so I get negative x squared plus 16x minus 64, and then the 65 is still there. So final answer, when I combine my two like terms right here, I get negative x squared plus 16x, negative 64 plus 65 comes out to be a 1. So this would be the flight path for the new golden fractals. Okay, all right. I hope you guys understood this, and go ahead and work on the homework, those word problems. See you later.